long. And 2019, January 21st, there'll be another total lunar eclipse visible from the Central Pacific, the Americas, Europe, and Africa. That'll be an hour and 2 minutes. So they do vary from eclipse to eclipse. And this one is just fairly short.
Oh, I just took myself off my Twitter feed here. Let me go back. I was reading questions. The one I was just seeing was a statement that someone was saying they're in Norway. And of course, it's sunny and morning there. So we want to thank our friends and fans in Norway for joining us. This question from @Chris19MLA is, what is the temperature on the moon and when it reaches totality? So does the temperature change when it goes into Earth's shadow?
That's an interesting question, and yes, indeed, the temperature changes quite a bit. The Apollo astronauts actually had to deal with this too, because if they were in full sunlight, it was very hot. If they got into shadow, say into a shadow of a rock, or even the lunar module, it would get much colder. So yeah, the temperature on the moon changes quite a bit as it goes from full sun to darkness.
That's a great point. I know talking about 100 degrees Celsius of a shift between sunlight and shadow. So yeah, you're right. It's definitely a huge change. 100 degrees Celsius during the day, and about minus 150 degrees Celsius at night. And so one thing, and I've been waiting for this as we get closer, because the dark side of the moon is, obviously it's a great Pink Floyd album, but people always talk about, you know, the dark side of the moon.
I'm impressed that you know about that album.
Oh man,
you're so young.
You don't know. Oh well, thank you. But the crack staff here is laughing. That's a timeless album. I know Jonathan and Tyson have listened to that music a lot. Our Marshall Television production crew here in the studio. And so the dark side of the moon is kind of a misnomer here at NASA. We always refer to it as the near side and far side of the moon. And so if you wanted to give us a little explanation of why we refer to it as near and dark, near and far versus the dark side.
Well, the moon always keeps one face towards Earth, but it does not always keep one face towards the sun. As it moves around Earth in its orbit, right now it's getting full sun on this side that we see, but as it moves around Earth, the far side begins to get more and more sunlight, and so there will be sunrise and sunset essentially, and a terminator. The terminator is that area between sun, where there is sun on the moon, and where there is no sun. That will change throughout the month. So the near side gets a half a month of sun, and the far side the same.
Yeah, there's a lot of really cool content that we talk about this when you talk about the near side and the far side. As you mentioned, it's that geosynchronous orbit. So that's why we always see the man on the moon. Always, because that same side is the side that we see all the time. Even as the moon moves further away every year, it's still this near side is always facing. So in that rotation, there is a dark side of the moon. It's just constantly changing because, as you mentioned, one time it might be dark on this side, and other times, so the moon orbits and the entire moon gets a little bit of sunlight. So it's a little bit of a misnomer. So we always try to encourage everybody to use the near side and use the far side. One thing that's really good about the far side we always talk about is we use the near side for lunar landings for the Apollo missions. The side that we see, the face of the moon, because that's direct line of sight for radio communications. If we were to land astronauts or rovers on the other side of the moon, we would have that direct line of sight of communication. The only way we'd really be able to relay would be have some kind of satellite orbiting the Earth, orbiting the moon that could relay that information. But that dark side, or that far side of the moon, is a great place for radio or microwave bases that could reach out and not have our interference from Earth to get really deep into the universe and the solar system. And so maybe in the future we'll be able to have some bases on that far side of the moon. We'll just have to have some orbiting satellites for communications. You can see we are closing in on the totality, the umbra, of this April 4th, 2015 eclipse. The third in the tetrad series of 4 that we're experiencing between 2014 and 2015. 4 eclipses in a row. Great opportunity to share this with you on a live broadcast. We know a lot of people aren't able to see it. If you're in the United States and the Americas, you'll be able to see it if you're on the western side of those countries, as well as if you're Pacific Ocean and the bordering regions of Asia and Australia. So Eastern Asia and Western United States are able to see tonight's eclipse. It won't be visible in Greenland and Iceland, Europe, Africa, and the Middle East. And so as we look at our Twitter feed, we see, and we're very fortunate and very thankful. We see a lot of people posting and tweeting from Norway and Europe, the different European countries. And so we're glad you're joining us either on our live stream feed or sharing some content on social media. You're not able to see it, but you can still participate. So it's a great opportunity. And so as we go into this full lunar eclipse, Mitzi, give us a little more information. How excited are you to see this eclipse? And I'm sure you've seen quite a few. You seem to be working these all the time.
I really enjoy all eclipses, lunar and solar, but I believe we have a video just now.
Total eclipse of the moon, presented by Science at NASA. It's déjà vu all over again. For the third time in less than a year, skywatchers in the United States can see a total eclipse of the moon. The action begins at 3:16 a.m. Pacific Daylight Time on the morning of April 4th, when the edge of the moon first enters the amber core of Earth's shadow. For the next hour and 45 minutes, Earth's shadow will move across the lunar disk, ultimately covering the entire moon at 4:58 a.m. Pacific. East of the Mississippi River, the eclipse will be interrupted by sunrise. People can only see a partial eclipse. West of the Mississippi, people can see the whole thing, including totality. Totality is when the moon is fully inside Earth's shadow. Some total eclipses last for more than an hour. In this case, however, totality spans just 4 minutes and 43 seconds, a result of the fact that the moon is skimming the outskirts of Earth's shadow rather than passing centrally through it. The brevity of the eclipse highlights the importance of watching the clock. Be outside no later than 4:58 a.m. Pacific to witness the red moon. Why red? A quick trip to the moon provides the answer. Imagine yourself standing on a dusty lunar plain looking up at the sky. Overhead hangs Earth, night side down, completely hiding the sun behind it. The eclipse is underway. You might expect Earth seen in this way to be utterly dark, but it's not. The rim of the planet looks to be on fire. As you scan your eye across Earth's circumference, you're seeing every sunrise and every sunset in the world, all of them, all at once. This incredible light beams into the heart of Earth's shadow, filling it with a coppery glow and transforming the moon into a great red orb when viewed from Earth. The total lunar eclipse of April 4th, 2015 is the third of 4 total lunar eclipses separated by approximately 6 months, a phenomenon astronomers call a tetrad. Such a closely spaced succession of eclipses is a fairly rare occurrence. The complete list of dates is April 15th, 2014, October 8th, 2014, April 4th, 2015, and September 28th, 2015. Set your alarm before sunrise on April 4th and enjoy the show. For more news about beautiful events in the night sky, visit science.nasa.gov.
What's up for April? A total lunar eclipse. Hello and welcome. I'm Jane Houston Jones from NASA's Jet Propulsion Laboratory in Pasadena, California. On April 4th, be on the lookout for a total lunar eclipse. A lunar eclipse takes place on the night of a full moon when the moon is on the opposite side of Earth from the sun and the moon passes into Earth's shadow. This can occur only when the sun, Earth, and moon are all aligned. An eclipse begins when the moon first moves into the less dense part of Earth's shadow, what astronomers call the penumbra, then into the deepest shadow, or umbra. The April 4th lunar eclipse covers the Pacific and can be seen from parts of Australia, New Zealand, and Eastern Asia to the western parts of North America. Here are the times for the various stages of the lunar eclipse on the west coast of the United States. On the east coast, the eclipse begins near dawn, and the moon will set before the eclipse has ended. The total eclipse, the brief phase when the entire surface of the moon is obscured, will last about 12 minutes. For those on the west coast, the eclipse will end at 6:45 in the morning. Later in April, you can enjoy other ways of seeing the moon. It pairs with the Pleiades and Venus on the 20th and 21st, and passes below bright Jupiter on the 25th to the 27th. Another sky treat this month is the Lyrid meteor shower, which peaks in the early morning of April 23rd. The constellation Lyra, the point in the sky where the meteors appear to radiate from, will be above the horizon before midnight and high overhead by dawn local time for Northern Hemisphere observers. You'll see more meteors when the radiant is higher, between 4 a.m. and dawn. Based on observations from the past 2 years, you can expect to see 15 to 20 meteors per hour, perhaps more. Information about our solar system objects can be found at solarsystem.nasa.gov, and you can learn about all of NASA's missions at www.nasa.gov. That's all for this month. I'm Jane Houston Jones.
Those are great videos, excellent content that is produced by NASA media and science experts all across our field centers. A lot of people are familiar with NASA. NASA has field centers all across the United States. We've got 10 different field centers, and if you're in the United States, we've got centers in Texas and Florida. Most people are familiar with the Johnson Space Center in Houston, Texas, where the astronauts train. Most people are familiar with the Kennedy Space Center in Cape Canaveral, Florida, where our launches take place from, not only where the historic Apollo missions to the moon and the space shuttle launches took place, but also our expendable launch vehicles. But a lot of other centers, including the one that we're at right now. Good morning and good afternoon or good evening, depending on where you're joining us from. My name is Christopher Blair, and we're broadcasting from the NASA Marshall Space Flight Center that's in Huntsville, Alabama. And I'm joined by a very special guest of ours who continually comes out and supports these late night events, social media events and broadcasts for lunar eclipses and solar eclipses. Dr. Mitzi Adams is here, one of our astronomers and scientists, and glad to have you here, Mitzi.
Let me first say I really appreciate the promotion, but I'm not a doctor.
Oh, I keep saying it?
I have a master's degree in physics.
That's right.
And I'm very proud of it.
That's right. You mentioned it as Master Mitzi.
Yes,
I should have
that's
caught
me.
that.
Master Mitz.
I think I just typed it down as well. You're definitely smart enough. You got all that content. But like you, myself, I probably just don't want to spend the money to go get a doctorate degree. We got all the background knowledge. And so we're sitting here, we're taking questions live on Twitter. If you want to tweet your questions to @NASA_Marshall, use the hashtag Eclipse2015. And we're trying to go through and answer as many questions as we can. Obviously, NASA has a lot of fans and friends across the globe. And so we're answering them as quick as possible. Our media specialists and public affairs officers are here in the studio, as well as myself. We're pulling a couple and having Mitzi answer them live, and then we're trying to backfill and answer the ones that are posting. If we don't get to your questions tonight, throughout the weekend we might catch us log on and answer some. I continue to like to be on NASA social media, excuse me, and so I might be on there answering some more questions later, but we definitely appreciate everyone, not only your questions, but your content and your comments and your images. There's definitely a lot of people that are out there. Just every time I refresh my page on our NASA Marshall Twitter account, there's a lot of content, so we appreciate it. And thank everyone for joining us as we see this live video feed of the April 4th, 2015 lunar eclipse. This feed is coming from the Griffith Observatory that is in Los Angeles, California. Our friends and colleagues out there, they support us for all these eclipses. Sometimes we're fortunate enough we have a television camera here in North Alabama that we will set up and we can bounce to that feed. Unfortunately, with this eclipse setting so low on the horizon, close to morning, we weren't able to get that feed here, but you can see we are moving, inching nearer and nearer to our totality of the lunar eclipse.
And I'd just like to say that I dashed outside to see if I could see the eclipse, and unfortunately, it's below there's a building across the street from us and a tree line, and I could not see it at all.
Yeah,
so thank you, Griffith Observatory.
Yeah, absolutely. We're east of the Mississippi River in the United States, and so those of us joining us live, you'll probably have the same, if not a worse view as it sits behind buildings and tree lines. And if you're going through the Appalachia parts of the country, it's already set behind the mountains. But if you're west of the Mississippi on the western United States, or if you're Eastern Asia, you'll be able to see the eclipse a lot better than our view here. So we get this live feed, and that's really great. And so some questions as we go through social media to kind of keep moving along is, why can't we see the other side of the moon? And we talked about that earlier, the near side versus the far side of the moon. The fact that the moon is in a geosynchronous orbit. The moon does rotate, so all sides of the moon get sunlight, but it rotates so slowly it's aligned with in its orbit. It keeps the same face of the moon always facing us, which is why we always see the same side, the man on the moon. And so
it actually revolves once a month, and it rotates once a month.
Yeah, it's a great way to put that. And I know and Suzanne Foxworth, our guest who joined us earlier from the NASA Johnson Space Center, it's one thing they focus on a lot is the difference between revolution and rotation. They sound a lot easier. They sound kind of similar, and they start with the same letter. The end with the same kind of prefix and suffix kind of things, but they're definitely different. And if you're not quite certain the difference between revolution and rotation, take a few moments to go online and learn the difference. It'll really help you understand what goes on during these cosmological events. And so as we go through, one of the questions, I've seen this a couple times, and it could be from the same person, from Danny Malik 8 and several other people. How would climate change and pollution impact our view of future eclipses?
Climate change could impact our view of future eclipses simply by changing cloud cover. And pollution definitely could affect our view of eclipses because the color of the eclipse is determined by the particulates in the atmosphere. If we have a volcanic eruption, which can put dust and ash into the atmosphere, and it actually stays there for a long time, then the eclipses will be redder and darker, and so they could, from pollution, be much redder, much darker. Hopefully, though, pollution will decrease over time and not increase.
Yes, let's all keep our fingers crossed for that. But yeah, I agree with you completely. It's so great to have you joining us. I know myself and our team here, we work a lot of these events, so some of these questions we can answer by practice because we've answered them so many times, but it's great to have you and your expertise joining us here. And so I want to thank everybody for sending in images and content. I've seen a lot of great stuff. A couple quick questions, and people asked if they could see the eclipse in Orlando. Obviously, if you're on that east side of the country, you're not going to be able to see it. One question we heard earlier, I've seen a couple times, is NASA still sending people to the moon, missions to the moon. And so if you wanted to talk a little bit about what our future missions are, especially what we work on here at NASA Marshall Space Flight Center, which is the high priority of space launch system.
Yeah, we don't currently have any crewed missions scheduled for lunar exploration. But we do have ideas for exploration of the solar system, which will require the SLS, Space Launch System. During the days of the Apollo program, we had a rocket called the Saturn V, and that rocket stood 363 feet tall and had some incredibly large engines that got the command module and the lunar module out of the gravity well of Earth. And it requires a great deal of thrust, a really big rocket to do that. And that's why NASA has to have this Space Launch System in order to get any kind of crude exploration of the solar system, either to the moon or to Mars or to large asteroids. All of those are within our plans, but nothing specific has been, no specific dates have been set yet, because the first thing we have to do is get out of the gravity well. And that's the biggest hurdle. So developing that large lift vehicle is a high priority.
Absolutely. You mentioned the gravity well, and so a lot of different content in that is sending crewed missions obviously requires more gear and equipment and supplies. All that is extra weight, all that means extra fuel, all that means larger rockets, and getting the hard part, as you mentioned, just really getting off of Earth's surface and that pull of gravity. Once we get above the higher parts of the atmosphere, it's a lot easier for us to manipulate and move around. And so as we develop the Space Launch System, NASA's next deep space exploration rocket, we've been to the moon, and as we heard from Jeremy Kent and Suzanne Foxworth, we actually have a little over 800 pounds of Apollo moon rocks that returned on those 6 Apollo missions. So a lot of that is at the Johnson Space Center, where we are able to conduct scientific research. And so we've been there 6 times. And so one great thing about the Space Launch System is that it's going to move us beyond crewed missions to the moon, to where we can go to Mars, destinations beyond asteroids. And one thing we mentioned, we work here at NASA Marshall, is the Space Launch System. But there's a lot of other really cool, exciting missions that are coming up. The Space Launch System will help put the Orion capsule, which is our crewed vehicle that would carry astronauts, which, in fact, here at NASA Marshall, we have the heat shield from its recent December 2014 flight test, where we launched the Orion capsule up into Earth orbit on a Delta IV rocket, and we returned it, splashed it down in the Pacific, and we're able to bring it back here in the heat shield. We're doing testing and post-analysis on that now. But if we talk about crewed missions and uncrewed, there's another mission that's out there. It's called OSIRIS-REx, and it's a proposed mission that we're working on to send a robotic lander to an asteroid called Bennu, or Bennu. I think that's how you pronounce it. B-E-N-N-U. And so it would actually, it's the first U.S. mission that would return asteroid samples. And so not only are we working on crewed missions to go to other destinations in the solar system, we have uncrewed missions, spacecrafts and satellites that we launch on these expendable launch vehicles that will go out into different parts of the solar system and come back and return samples. And so definitely a lot of content that we're trying to get out there and just expand our knowledge. And so going back through, as we are nearing our eclipse of the April 4th, 2015, some more questions and content. We keep talking about the eastern side of the United States may not be able to see this eclipse as well. It's definitely going to be low on the horizon, and so those folks joining us, as we mentioned, in the Smoky Mountains or the Appalachia Mountains may not see the eclipse, but I'm seeing some good photos. I've got at Vulcan MS Katie has sent 2 images where she can see the eclipse from South Florida. It's very flat in Florida, so she's got a great view, and it's right on the horizon, setting on some palm trees. The weather looks really great there, so we appreciate that. I appreciate you sharing us that photo.
When I went outside about 10 minutes ago, it was very, very bright outside here in Huntsville, and I could not see the western horizon, so I could not see the eclipse. But I believe the sun is up on the East Coast, so for those trying to view the eclipse in Florida, it may be a little difficult, and the moon, basically kind of the definition of full moon is that the moon will rise as the sun sets and vice versa. So as the sun rises, the moon is going to set. I'm afraid if you're on the East Coast, the eclipse is over for you. But if you are west of the Mississippi, if you're in California, as is our feed from Griffith Observatory in Los Angeles, you're getting a good view, and we are just about to enter totality. For those of you who'd like to do some timing, it'd be interesting to see how long this totality really lasts. To the north of the moon, we have a Plato crater, Mare Frigoris, Aristoteles, and Endymion, and they are disappearing from view now as the eclipse enters totality, or begins to enter totality. And I hope that you, wherever you are getting a good view of this eclipse.
I know, as you see a little bit of the northern part of the moon, you know, it's an egg-shaped moon. It's not round, very egg-shaped. And we talk about where the Apollo astronauts landed, and you can't see any of the landing sites now. All the landing sites from the Apollo missions, they were all on this near side, and they're all based around the equator. So right now, if you were trying to look at some of the landing sites from the 6 missions, they'd all be in the shadow of the moon. But some of our missions that NASA sent, we talk about the Lunar Reconnaissance Orbiter and its smaller sub-satellite or sub-impactor, the L-Cross mission. One great thing about seeing the northern part of the moon and the southern part of the moon is the idea that deep in those craters, because the moon doesn't have an atmosphere and it's impacted all the time by meteoroids and meteorites, that deep inside those craters that there's actually parts of frozen ice that's left over and that there's water on the moon. And so it's one kind of thing now you can see where we would want to have potential lunar bases in the future, whether they're NASA bases or whether they're private corporations, as we begin to see a lot more of privatized space exploration. That might be places, that's one place, northern and the southern hemisphere we want to have lunar bases at. And so going through some of our questions, we know that the moon affects the tides here on Earth, the gravitational pull. And so does an eclipse affect the tides?
The eclipse itself does not affect the tides, but the fact that the moon is full for an eclipse to occur does.
It's good, I like that part. Let's see here, scrolling through and pull a few more pictures. Oh, you know, I'm going to refresh. Yeah, and I liked your other suggestion. Please, we have told people that it's about a 5-minute of totality for the eclipse. And so, yeah, if you're out and you're viewing the eclipse, feel free to time it and tweet us and let us know exactly kind of how long it lasted. That's a great way to be involved. NASA always likes interaction in our events and activities, whether it's in person and you're working and talking with us, or joining us today on social media. But yeah, this is a good way to kind of do peer-to-peer science. And NASA definitely employs some opportunities like that where we have the population, our fans and friends joining us for different kinds of scientific research. And so great opportunity if you could get out there and do that.
If you look at the feed there, we're beginning to see a little bit of coloration.
Absolutely. Often misnomered as the blood moon. You talked about that earlier, the fact that that's the rising sun and filtering light through the atmosphere. So it gives us that blood moon, which is, you know, doesn't really have, it's kind of a nouveau word we mentioned earlier. It's just because it kind of turns red by filtering out that blue. And it's very exciting to see all this happening. Want to once again thank the Griffith Observatory. And so let's kind of go through here and pull a few more pictures as we see some of these great contents people are sharing. They're asking what time could they see from Louisiana and when would it be full. Louisiana is about the time frame right now where we're at, depending on east side or west side of Louisiana if you're in the Baton Rouge or the New Orleans area. So I would suggest you go outside right now. And if you're lucky, it's pretty flat in Louisiana, so you might be able to see it as well. And we've got people here in Montgomery, Alabama, who's asking where they can go to see the eclipse. And as Mitzi mentioned just a little bit ago, the eclipse is definitely setting on the horizon. The best place to go would be on top of one of the mountains, and then you might be able to get a good view if you're lucky. But for the most part, where we're at here in Alabama, it's going to set before we probably get a good chance to see the eclipse happening. And so
Moonset here in Huntsville was 6:34 Central Daylight Time. Louisiana would be a little bit farther to the west, so you might still have a bit of moon visible above the horizon, but it's questionable.
See some people who are great retweets, and that's one thing about our fans is they definitely share our content. So I see lots of retweets as our fans inform their fans It's a great way to get out there. I tell one person, that person tells 5 people, and that person tells 10 more people. And next thing you know, everybody knows that we're having a lunar eclipse. And so we want to thank all our people who are retweeting and sharing our content out here. A lot of the great content, people are saying, hey, it's will it turn orange or will it turn to red tonight? And as we can see, we are getting a little bit of that red tint happening. That's very exciting to see that. I want to thank everybody for all the positive comments that we're getting on NASA social media. A lot of people are having fun times here. And so in terms of frequency, this is a question from @AstroFellow. That's a good Twitter handle. @AstroFellow, he or she is an aspiring astrophysicist, so they're probably enjoying listening to all your content. And in terms of frequency, how evenly do visible eclipses spread for particular places on Earth?
That's an interesting question. I'm not quite sure how to answer it because if we're talking about lunar eclipses, if it's dark, you ought to be able to see a lunar eclipse. So that could be half the Earth, and that's my best. I think that's my best stab at that.
Well, that's a tough question. Obviously, we've got someone who's studying astrophysics, and so high-level questioning. And while you're joining us, one great thing we've heard from some of our guests and whatnot are some of the educational opportunities. We want to give a plug for, we've been giving plugs all day, the Space Launch System and some of our upcoming missions, but we want to plug our internship program. It's a chance for students who are in the college and studying various degrees to go on to nasa.gov. You can Google this, actually. Just Google NASA internships. And we have internships at all the centers across the country, East Coast to West Coast. And so you can find these internships. And it's not just for people who are studying science and astronomy. It's great if you want to be a rocket scientist. We definitely are looking for more of those. But as you're joining us live here through the magic of television, we've got television producers and social media experts. We have lawyers and doctors and graphic artists. We have educators. There are just about almost every job you can think of in the real world. We have a place for you somewhere here in NASA Business Administration. The way I always explain this is that, I get paid every week like everybody else at a normal job, but it sure isn't an astronaut who brings my check to me. It's someone who works in the finance department who has an accounting degree. If we have issues here where the lights go out or the plumbing goes bad, we don't call the astronauts to come and work on this. It's electricians and computer technicians or welders. And so there's definitely a lot of different jobs. And so it was great to have that question from an aspiring astrophysicist. But please, anybody who's interested in working in NASA, just go and check on NASA internships. They have internships at all our different field centers, and you can join us right here. We've actually got a couple who are coming into the newsroom here at NASA Marshall Space Flight Center. They'll be coming and joining us this summer, and so it's exciting to have two young students who are interested in working for NASA. We're definitely this is a great eclipse and a great view from the Griffith Observatory. We want to thank them. Looks great color tonight.
Yeah. Yeah, we got the reddish color there of the moon to the south, and we are just about in totality. I would say maybe a minute away, perhaps. And this totality is right around 5 minutes for this eclipse. The shortest one in the last 500 years was 1 minute 41 seconds. In 1529. So that
Wow. That is pretty quick. That hustles through. Usually on a planetary cosmological scale, things don't happen that quickly. But wow, 2 minutes. I didn't know that.
Yeah, 1 minute 41 seconds.
Going through some of our questions and just kind of reiterate some of our answers. We mentioned this earlier. This one's at Chill Park. She was asking, when will a total lunar eclipse be impossible to see due to the moon moving away from us? And it might be a little hard to come up with a time frame, calculating that math of the inches that moves away per year.
Yeah.
But it's obviously a long time.
It's going to be a very long time.
We won't be around.
I don't think we'll be around.
I hope we're around as a race. But yeah, absolutely, if the moon does move a little farther away. And so it's a great question. And another one that was shared is, I like this because we're trying to educate people while we share this content. At Miklos Lexo. And it's the idea, is rotation and revolution exactly the same, or will the far side eventually become the near side? So obviously, revolution and rotation aren't the same, but if we're talking about the moon moving further away, right now it's geosynchronously locked, so we always see that far side in that 27-day pattern around its orbit around the Earth. But if it's, and I was reading this at some point in time, that obviously 27 days now, but in 1,000 years it'll be 50 days. Basically, a month would be 50 days if you think about it, orbiting around the Earth.
Yeah, I think it's probably a good idea too to back up and define what rotation and revolution are. Rotation basically is when a planet or a moon turns on its axis, rotates around its axis, and revolution is when a planet or a moon moves around its parent body. So our moon moves around the Earth, that in 1 month, that's a revolution. Earth moves around the Sun in roughly 365 days. That's one revolution around the Sun. But as the moon moves farther and farther away from Earth, I would expect that there'll be a lot of perturbations in its orbit, and it may begin to wobble a bit. But I'm not sure I can really exactly answer that question of whether the far side will become the near side.
I'm trying to answer one of our questions now.
Take a look at the feed, and the color is I don't know. I would call it kind of reddish. Perhaps it's a blood moon.
God, that looks great, doesn't it?
And note how bright it is still on the north side. And that is the edge of the umbra and penumbra. So the edge of the umbral shadow of Earth and the penumbral shadow of Earth.
One thing we mentioned earlier, and it's great to highlight this for all our viewers who are joining us, especially as you start to wake up. I want to thank you for joining us here on our live stream as we bring you this live coverage from the video is from the Griffith Observatory, and we are joining you at NASA's Marshall Space Flight Center in Huntsville, Alabama, North Alabama. And so one thing we talked about now that we're starting to see a little bit of the colorization, we could also start to see the highlands and the lowlands that kind of disappeared for a little bit. And we mentioned how the temperature fluxes back and forth between sunlight and shadow. And so you can kind of see now where some of the Apollo lunar landing sites were. You can see those Maria.
Yeah, the Apollo lunar landing sites were all clustered around the equator of the moon, and initially they were chosen to be as free of rocks as possible. I know that Apollo 14 landed in the lunar highlands in the Fra Mauro region, and they, as all of them did, they made sure that as they landed, their landing site was as free from rocks as possible.
Some of our questions coming through in content just to help some people. Some tweets from @jhosa2008 is letting us know that the moon has disappeared in Billings, Montana. So all our fans who are joining us in that section of the world, you've probably missed that eclipse, but fortunately you can join us right here and see it live. One of the questions, we were talking about internships earlier. This is another inspiring aerospace engineer at DEMX98 is asking, are there programs for high school kids? And I was talking about internships for college students. And so are there programs for high school kids? That's a great opportunity, a great question. I want to continue to encourage everybody. Tweet your questions to us. At NASA_Marshall is our Twitter account. Use the hashtag Eclipse 2015, just like at DMX98 did. And his question about high school opportunities. And so, great question, and that segues right into something that we do here at NASA's Marshall Space Flight Center in Huntsville, Alabama. We have a program next weekend and the weekend after that. We have a program that's called Student Launch. You can find it if you go online and just, or even on Twitter, just hashtag Student Launch. and that's an opportunity for high school and actually middle school, high school, and colleges and universities across the United States to come here and launch high-powered rockets, very high-powered rockets. We're talking 6-7 foot tall rockets that will launch up to an altitude of 1 mile in the sky. So you want to learn a little bit of how your university or school can start a rocket team and come here. It's very technical. It's very high-quality content. It's not for the faint of heart. Another program we have here in 2 weeks is called Rover Challenge. And what that is, same thing, high schools and colleges, universities. This one is global participation. In fact, for this year, we have, I want to call it about 90 teams from 18 states, but we also have teams from Puerto Rico, Mexico, Germany, India, and Russia who will be here. Very international collaboration. Teams who will come here for Rover Challenge. They design and build a human-powered 4-wheeled, 6-wheeled, 3-wheeled buggy or a rover, and they bring it here to the United States Space and Rocket Center, our official visitor center, and go through nearly a 3/4 mile long obstacle course. And you're going to see a lot of social media content being posted now as the event's near. Hashtag Rover Challenge, hashtag Student Launch. And the great thing about those events, we also stream those live right here on our Marshall Ustream page, as well as have them often picked up on NASA television. So next Friday and Saturday, and also the Friday and Saturday after that, log on here and join us live. It'll be myself and some of my other colleagues, the television crew who's joining us today. We'll be streaming literally all day coverage from almost sunrise to sunset as 100 teams or 50 teams come in different weeks. So that's a great question and an opportunity to plug all the hard work that we're going to be doing next week for both those events. And everybody will enjoy that. So a lot of fun and opportunity. We've been making some fun shareables and some memes that we'll be sending out so people can get an idea of what's happening. Going through, looking for some questions and some content we're getting. Obviously, the lunar eclipse is over for people on the East Coast. Glad you actually had a chance to see it. And in Toronto, the moon has set. So our fans and friends in Toronto, thanks for joining us on Twitter. And we're definitely seeing some colorization, Mitzi.
Yeah, and again, note towards the top of the image, the north part of the moon, it's very bright, which is the area which marks the boundary between the umbral shadow and the penumbral shadow. And the moon continues to move in its orbit around Earth, and it is beginning to move out of the shadow, actually. But we can see the color of the eclipse is a reddish, and these colorations vary from eclipse to eclipse depending on what's in the atmosphere. You can have even a grayish eclipse. This one obviously is reddish, which is very pretty and could be called the blood moon. I should note again, for those who weren't listening earlier, that this full moon, and you have to have a full moon in order to have a lunar eclipse, this full moon is called the pink moon, named after the plant, the pinks, that begin to bloom in the spring, especially here in the south. But that would be kind of opposite the harvest moon, which we would see in the fall.
And highlighting, going back to the idea of the blood moon and the pink moon, one of the questions that we received on NASA Twitter is, how long will the moon be fully blood red?
Not very long. As soon as a substantial portion of the moon moves out of the shadow, it will begin to, the bright part will overpower the shadow of the Earth, and so the color will change very rapidly.
We've got some questions here and some content. Want to thank EWB4669 for joining us. They are in central Utah watching the moon. This is just about 15 minutes ago. It was 98% covered, and he's up with his kids, and so that's excellent. A wonderful opportunity. Sounds like a great family. I've got another @N Meekum. They're in Boston, and they were curious if they'd be able to see the lunar eclipse because it's very cloudy there, and I will take a stab at that one. I'm pretty sure that if it's very cloudy, then we're not going to be able to see that one. But we definitely want to thank you for joining us and watching our feed and participating. This one I like. This is once again just our fans and friends who are sharing content in Slovenia. They're not able to see the eclipse, so they tweeted a picture of our live stream.
Excellent.
Yeah, great. And shares that with their friends and family in Slovenia who aren't able to see the eclipse live, but they can follow their Twitter account. So I want to thank them for that.
Let's see, it would be daylight in Slovenia, I believe.
Absolutely. And you can see, obviously, the moon orbits Earth pretty quickly, and so you can see the moon throughout the day as well as the night. Depends on the phases of the moon. But you wouldn't be able to see an eclipse during the day as well as a full moon.
No, because in order to have an eclipse, you have to have a full moon, and kind of the definition is that the moon is opposite the sun in the sky. So when the sun sets, the moon rises, and when the moon sets, the sun rises. So in order to see the full moon, you have to be in darkness.
So you're talking about being, line of sight, kind of sun, earth, moon, in a straight line. And so one of the questions I saw, and I'll kind of see if I can find who it was. Here we go. This is let's see it, at Hits Tarek, and he was asking, what does the lunar eclipse look like from the moon?
Yeah, that's an interesting question. I believe we actually have some animations of what it might look like, but if you were on the moon looking back towards the sun and the Earth was completely blocking the sun, because Earth is about 4 times larger than the moon, it would not be exactly the same size as the sun, so you wouldn't get a total solar eclipse like you would get. It wouldn't look exactly the same. You get this ring, a kind of an annulus of color around Earth, and that ring is due to the atmosphere of Earth, and it's due to sunlight being filtered by Earth's atmosphere, and the blue light scatters, refracts out, and you get the red color.
That is a great animation.
That is a great animation.
That's super. We obviously can see the eclipses here from Earth, but yeah, that aspect of being on the moon and looking back at Earth as the sun moves in between it and blocks out the sunlight, that'd be a great view. Love to see something like that one day. And
so would I.
If nothing else, I hope somebody gets to see that one day. And that goes into a question here from @ShrekMLG420. And they're asking, if astronauts were on the moon during a lunar eclipse, would that affect their mission? Would there be any changes to their mission if they were to actually see a lunar eclipse?
Well, if they were on the moon during a lunar eclipse, they would be totally engulfed by Earth's shadow. So, as we discussed earlier, the sun would not be reaching the moon at that time. Temperatures would go down, so they'd have to be prepared for that. Also, if they were using any solar panels for power, if their batteries were not fully charged for the length of time that they were in Earth's shadow, they would lose power for whatever they happen to be doing. So they would have to plan for it, yes.
Absolutely, and you can bring up a great point about the solar panels. That's the same effect for the International Space Station. It continually orbits the Earth. It's about 220 miles above us right now. A lot of people get confused about the International Space Station because they just kind of view it as a spacecraft that's traveling through space, when in fact it's really not too far. 220 miles, that's between here to Montgomery. It's not that far in terms of distance. It's just the fact that it's straight up above us. And so they're continually moving around. So they see sunrises and sunsets several times a day. It means they're on a dark side of the Earth, and they use that solar power and store their batteries. And it would be the same for any missions to other planets, whether it's you're losing sunlight because of an eclipse or a rotation or a revolution, or planetary geology, something like a weather pattern. If you're on Mars, for example, with our rovers, and the dust storms come through and you have so much dust in the air and it blocks out the sunlight.
I actually have solar panels on my roof at home, and I've noticed that they're now covered in pollen. So I'm they're less efficient, and I should go clean them. Although I guess they probably got cleaned last night with our rain.
That's yeah, you're actually right. We and the references, we had some wicked severe storms go through last night with up to 60-mile-per-hour winds and possible tornado touchdowns within the area. And so I bet with that storm you probably have clean.
I probably do. Probably do.
That's great though, and especially the pollen. I would have thought about that. So you're kind of comparing, contrasting the same difficulties of spacecraft on Mars to your home solar power electricity.
Exactly.
It's great having you here. Once again, our live feed, as we're bringing a live feed from the Griffith Observatory in Southern California. I want to thank them. A lot of our followers here on social media have noticed, as well as we have, that depending on where you're at on the United States, you weren't able to see the eclipse, or you're not able to see the moon now where it's already set, especially our viewers and fans on the East Coast, the eastern part of the United States. And so we want to thank everybody on the western part, especially the Griffith Observatory. It's a great feed. We're seeing a lot of colorization and some of what's been noted as the blood moon. And want to thank at Anna Gabrielle Lido. That was a mouthful. I'm going to say it again. At Anna Gabrielle Lido, for retweeting and sharing some of our content. It looks like they're getting ready to do some kind of live feed, and so she's kind of letting people know that we're up. And I want to also thank at Photo Caitlin for thanking us for the great info, and really thanking you.
Oh.
You're doing most of the hard work here.
No, I think you're talking more than I am.
Let's see if we can find a few more. We did the lunar eclipse one. How about, let's see if we can find a few more questions here. You know what? I'm going to refresh my page here. While we're doing that, what else we got going on with our moon, and when can we expect to see other eclipses and some of the features that we're seeing? And
well, we can expect to see another lunar eclipse later this year. September 28th will be the 4th total lunar eclipse of this tetrad, and it should be, for us in Huntsville, it should be kind of fantastic time-wise, because I believe it begins sometime around 9 o'clock in the evening, Central, and that'll be Central Daylight Time, and it'll end around midnight. And so we will not have to get up at 3 o'clock in the morning to see that one. We can just stay up through the evening and postpone our morning run for the next day for a little while. But it should be, I'm hoping that we have good weather here in Huntsville, and I'm certainly hoping that Griffith Observatory will partner with us again, and that Los Angeles will have good weather, although I certainly do hope it rains in California before then. You know, a while back we were talking about meteors and meteorites and meteoroids. Do you know the difference between those terms?
Myself, yes, based on the location of where they're at. Meteor, meteoroid, and meteorite. Depends on its location, whether it's in space and coming. But I'll let you explain that so everybody knows. I think that's great. We talked about the difference between revolution and rotation. And so, yeah, please give our fans and viewers that difference.
Well, we can actually pick up meteorites, some meteorites that have fallen from Mars and from the moon. Sometimes we can find those kinds of things in Antarctica. And when I say meteorite, it refers to a rock from space that has fallen onto the Earth and has literally fallen, and we can pick up as a rock. And then we have meteoroids, which are that same piece of rock, but you would find it in space. And then the meteor is when that same piece of rock enters the atmosphere. So you go from space, meteoroid, to meteor when it's in the atmosphere, and meteorite when it's on the Earth.
Yeah, that's a great definition and explanation, and so we're trying to help everybody out. We have had a great time. We've got a lot more content, and so we're just informed that we actually have a reporter who's joining us live who wants to ask some questions to Master Mitzi. And so if you're able to hear us, would you please tell us your name and where you're from?
Oh, hello. Yeah, I'm just going to be transferring. We're just still a couple of minutes away. We're doing a live broadcast. So I don't know if you...
That's okay. Well, thanks. We appreciate it. We definitely want to get you involved, and so just stay on the line while we get everything going, and they'll give us a notification, and once they'll give me the cue, and we'll come back and let you ask questions to Mitzi, and in the meantime, we'll let her answer one of our social media questions, and I like this one. This one is from @McDonaldK2, and they're asking, what is the range of sizes for the craters that we can see on the moon? And so here we can see the dark parts of the moon, but we're talking about some of the craters, and so range of sizes for craters.
Range of sizes for craters. My goodness. The craters can be, as a matter of fact, the Apollo astronauts reported seeing very small craters, maybe, you know, a foot across, maybe even a little smaller, and they can range in size up to several hundred feet across.
With Mars doesn't have an atmosphere, so it gets pounded a lot more by, as you mentioned, meteorites that cause these craters. And because there's no atmosphere and there's no environmental impact, there's no weather patterns on the moon, it's a lot different than the craters that are on Mars. Most of the craters, if not all the craters, on the moon will be preserved craters. And one thing we always talked about, we did a lot of workshops on craters, was preserved craters, modified craters, and destroyed craters. And so on the moon, we'll have a lot of preserved craters. They are what they are. There's not a lot of geological weather impacts, atmospheric impacts. On Mars, though, you could have modified craters or destroyed craters because of environmental impact.
That's right. Mars does have an atmosphere. It's not very dense, but it does have an atmosphere. And so over a period of time, some of the craters can be weathered. You can have impacts on top of impacts, and we see that on the moon. And so those kinds of things can get your destroyed craters even on the moon where there is no atmosphere.
Yeah, you're right. Actually, I was talking about how because there's not a lot of atmospheric conditions on the moon that you get those preserved craters, but they can be modified and destroyed because of other impacts.
That's right. And there also there is also some weathering effect from the solar wind itself.
Yeah, solar wind particles. There's moonquakes. The moon does have moonquakes, and we're able to prove that by leaving some of the seismograph scientific material from our lunar missions. And so I believe we might actually have our joining reporter making a connection where we can get some live content and questions. So please, if you're able to join us, and we've got a great opportunity to share some content from our guest expert here, Mitzi. David, would you please tell us your full name, who you work for, and where you're located at? Oh, we'll keep trying. We've got them online. We'll get them through the system here in just a second. And they'll have some great questions that we can share with everybody, and then get some great answers while we've got Mitzi here in the studio. Every now and then I will faux pas and say Misty, and that's because I've been conditioned, because my wife's name is Misty. And so what will happen is when I go home, I will call her Mitzi, and I'll probably get in trouble. But I've got an excuse. So Misty and Mitzi have been a little trouble for me today. Let's see. If the moon stays in the shadow of the Earth too long, will the moon turn from red to dark?
No. And the reason is that the light that is falling on the moon is being filtered by Earth's atmosphere. The only way that the moon would be dark would be if Earth lost its atmosphere.
Absolutely. Want to thank @SailorLion for joining us. He says he's watching from Dayton, Ohio on NASA TV. I want to thank NASA TV for taking and picking up this feed and sending it out for everybody to enjoy. It definitely increases our range and audience globally. We stream this live here at NASA Marshall Space Flight Center in Huntsville, Alabama. We use our Ustream feed, and so we push this out for everybody to enjoy, and then NASA TV is able to pick this up and then give us a little more love and spread it out a little more globally. And so I want to thank everybody for joining us as we have Mitzi Adams one of our NASA scientists and astronomers here at NASA's Marshall Space Flight Center, joining us and giving us a lot of great content as we view the third of the eclipses for this tetrad. And we are joined by, on telephone, a reporter, I believe it's David. David, if you can hear us, would you please tell us your name, who you work for, and where you're from? But it's not a joke. April Fool's was the other day. April Fool's Day was about 3 days ago, so we're not playing tricks on you. We just trying to make the connection. We'll keep working on it, and eventually, well, we were going to try, but we might just have to get this question sent old school. Might have to snail mail it in. But we still want to thank them. It shows a lot of the interest, and so there seems to be some technical issues, I believe, on their end.
I'm really glad that we have the interest, and thank you to all of the reporters who have sent us questions yesterday and today. And I'd also like to just mention I have some friends in Guatemala who are astronomers, amateur astronomers, and I'm sure that they were watching this eclipse, although I believe that it would be in eclipse at moonset for those folks in Guatemala. And if you're listening to our feed, hello, and I'll come visit hopefully soon.
Will you take me?
If you pay your way.
If I pay my way. I've never been to Guatemala, but that's great, and I hope that they're joining us. And if they are, send us some questions. So this question is from @Master of Trolls. That's a good one, @Master of Trolls. I'm surprised he must have had that one a long time ago. What the question is, since we were talking about craters, does the moon have any underground volcanoes?
The moon does not have any volcanic activity currently, and it did have volcanoes, but not currently. And so no, there would be no underground volcanoes on the moon.
Yeah, absolutely. It was a geologically active moon millions of years ago. Volcanoes, lava flows, lots of basalt and whatnot, and of course that's over the time it's hardened. And that's one reason we can see some of the different areas, and that really leads into the next question. You can kind of show our experience here. We've done this before. @Skeeter Drain asks just a couple minutes ago, he thanks us for our coverage, so we appreciate that. And his question is, his children want to know, what are the dark spots on the moon?
The dark spots on the moon are the Maria. They are areas where lava has filled in low spots from when the moon was volcanically active.
Yeah, once again, we're talking about the fact that the moon was geologically active at a point in time, and you can see the actual impact and effects of that from literally millions of years ago and billions of years ago.
And I believe, if you look at the feed, I believe the total part of this eclipse is over, and the moon continues to move in its orbit around Earth and is moving into the penumbra on the other side of the umbra. And thank you, Griffith Observatory.
Hey, here you go. This is @AlexanderRC7, watching it live from #Guatemala. Since the sun is up and it's impossible to see the moon, they're joining us live and watching right now. So we didn't plan that one either.
No, I didn't plan that.
You probably don't know who this person is. Or it could be a good friend of yours. But how great is that we were just talking about that, and then here's our friends and fans from Guatemala. That's really great. And so another thing that's really cool is our fans will often answer the questions for us. So we want to thank everyone for helping us do our job. We're only so many people. And like this person here actually looks like let's see, I can do this. Oh, we actually heard from him earlier. @OHits Tarek was taking the time to answer the question about how the moon, the lunar eclipse doesn't affect the tides. The moon affects the tides, but the lunar eclipse is just the impact of the light and the rotation. And so I want to thank them for asking and helping with some of these questions that we receive.
That's great if we have folks answering questions, because that tells me that people are involved and they're interested and they're interacting with one another. That's fantastic.
I love living in this time frame, the science that we know, the technology that we're able to share. It's I want to live forever, become a robot like Sheldon on Big Bang Theory. And so just because I want to see what happens next. I think it's so great. And so at Susanna_Sears sent in a tweet question, and she was sorry to bug you, and trust us, you're not. But are lunar eclipses and sunrises ever visible at the same time?
Well, actually, I think we're seeing that now, because the basic definition of full moon is that the moon will set when the sun rises. And so in some places, the moon has set and as the sun rose. So if you are actually in Louisiana, perhaps, or Guatemala, or close to the Yucatan Peninsula, then you did see the moon in eclipse set as the sun rose.
Let's see. A lot of great stuff here. A lot of great contents. Do we know when the next eclipse is for Australia by chance? I know we know some of the next eclipses. But yes, this person is asking for Australia.
Let's see, October 8th. Oh, sorry, that was 2014. Apologies.
Yeah, we worked that one, actually.
Yeah, we did. There'll be a penumbral eclipse in March of 2016, but that penumbral eclipses are generally so subtle that it's very difficult to see. The next total eclipse after the one in October will be, in September, will be January 31st, 2018, and that will be visible in Australia with an hour, 16 minutes of totality.
That actually answers excuse me, some of the questions I've scrolled through and seen people want to know when the next eclipses are, so that they can join us live.
There will be a partial eclipse August 7th of 2017, and that will be visible in Europe, Africa, Asia, and Australia.
Some questions coming through. People are asking if the lunar eclipse affects the tides, and we've answered that one, that the moon does, but it doesn't affect our tides. This one is a great question. I always like to take these questions, and we get these a lot when we do Reddit AMAs. And this is for everybody here in the studio. Are we and the crew excited for Star Wars 7 to come out? Me, myself, I'm very excited for Star Wars 7. We were talking earlier about just how we love living this time and age of science, technology, and exploration. And so it's that thing that goes back, or does life imitate art, or art imitate life? And it's kind of the same thing for science and science fiction. Are we emulating the things we saw in Star Trek, or is it vice versa?
And on that note, I was saddened when I heard the news of Leonard Nimoy's passing, and he meant a lot to me growing up, and probably like a lot of science geeks, they wanted to be Mr. Spock.
Absolutely. And that's great. That kind of just shows how these things impact your life growing up, and how science fiction and art and technology, it shapes the future for the next generation of scientists and explorers. They see these things and they want to come and make them happen, make them real, make them exist. And so it's a great opportunity. And we're talking about some of the different jobs earlier at NASA, and we want to encourage everybody, come and join us, and you can be a scientist or an engineer, but we have lots of different jobs that are available, from public affairs officers to lawyers and medical physicians, welders, and computer graphic artists. A good friend of ours, budget analysts. A good friend of ours is in the studio right now working the control boards for television studio, and so if you're involved and interested in any of those things, then there's always a place for you here at NASA. And then let's kind of go through here and see. I'm trying to look for a few more questions. Will the space station be transmitting feeds of the eclipse from its perspective?
I don't know the answer to that.
I know that
Still images, perhaps.
Yeah, I don't know about live feed. We did see an image earlier on. I saw one earlier from the space station, where I saw it at, but it was definitely an image of an eclipse, and they probably saw, I don't know, 4 or 5 eclipses as they moved around and orbited the Earth.
Yeah, you actually mentioned the altitude of their orbit is 220 miles?
Yeah, 220, 230, kind of fluxes. Sometimes we have to boost it in orbit a little bit.
So they get to move around Earth fairly quickly. So the tighter the orbit, the quicker your revolution around the parent body. So Mercury moves much faster than Jupiter, for example. But yeah, 220 miles versus 240,000, 250,000 miles. So the space station does not get very far above Earth at all. And the space shuttle could only go to 220 miles, essentially. And a lot of people thought that the space shuttle could go much higher and much closer to the moon, but no.
Yeah, the space shuttle wasn't designed to go above low Earth orbit. The return flight to the moon and back, I'm sorry, to the International Space Station back. That was pretty much it. So if we want to do any kind of exploration above and beyond, we needed new vehicles beyond the space shuttle. And so that was one reason why we're so excited here at NASA Marshall and across the agency for the Space Launch System, which is our next deep space exploration rocket. If we want to go farther and farther beyond, we need a new vehicle. The space shuttle, and I worked at the Kennedy Space Center for years. The space shuttle was an amazing feat of engineering. It launched 135 missions. We launched it for 30 years, and it took componentry to space and satellites to space and astronauts, an international cooperative effort from countries all around the globe. Amazing. But what it couldn't do was go to the moon. I mean, first of all, it has wheels when it lands, so there's no landing strips on the moon, so it obviously can't go to the moon. And then when it would land, if it ever could land, it couldn't return. And so the shuttle was never designed to go anywhere except for up about 220 miles and then come right back down. And so the Space Launch System is something that we're excited about as we move forward. And so it's a very great opportunity for us to do deep space exploration and just expand our knowledge. And so once again, we have been broadcasting live here at NASA's Marshall Space Flight Center in Huntsville, Alabama, and we want to thank everyone on behalf of everyone here at NASA Marshall, all our friends and colleagues at the Johnson Space Center, Jeremy Kent and Suzanne Foxworth in the Astromaterials Research and Exploration Science Office, who joined us earlier today, all our friends and colleagues at the Griffith Observatory in Los Angeles, California, who've provided this feed all night long. I want to thank you for joining our broadcast and playing along on social media and Twitter. It's been a great experience. We've got a lot of people, a lot of questions and content. We're going to spend the rest of the weekend kind of pilfering through and trying to answer as many questions as we can. Want to give a quick shout out for our upcoming events, the 15th anniversary of NASA Student Launch, with nearly 40 middle school, high school, and university student teams who will be joining us here in Huntsville, Alabama next Friday and Saturday, as well as the 21st anniversary of a rover-based challenge event with 100 high school and college university teams from all around the world joining us. And thanks to our crack staff in the television production crew, we're going to live stream those events. So all day Friday and Saturday for the next 2 weekends, you can join us live here on Marshall Ustream as well as NASA Television and get a chance to see some really great STEM-based content, science, technology, engineering, and math. And so I want to give shout outs for those. I want to thank everybody who's been joining us. This has been a great, wonderful event. And until we get to see you again, thanks for joining us. Good night.